Okay, so the questions that we had in class today really had to deal with page 482. So I'm going to go over a couple of these problems with you, so maybe you can feel a little bit more comfortable as the rest of the class did today. So here's the problem. What we want to do is we want to solve this using logarithms by rewriting the problem in log base 10, okay? And remember that that 10 doesn't have to be written, it just automatically exists, but I'm not going to write it from now on. So when we see log, we just know that it's base 10, okay? So log equals log base 10. That's what we're talking about, okay? So once I get this done, I can use my laws because when I have the exponent, I bring it out front, it's multiplication. I divide everything through by log 3, right? So when all is said and done, I get x equals log 30 over log 3. And so when I have that, what can I do? I know that I can simply just put this into my calculator, right? So I can state that this here is the answer. It asks you to put it as what you would put in your calculator, right? Okay, it says give the solution in calculator ready form. So this is the calculator ready form, and then I put that into my calculator, and I get x is approximately 3.0959, but then it says 3 significant digits, so I write that as my final answer, okay? So now we're going to do another one that's a little bit more, it's the same process, but there's a little bit more to it. And again, I go through the same process of rewriting it as logs. Okay? So again, I go through the same process, and I divide by log 5 so I can get t alone on both sides of the equation. So my calculator ready form would be log 10 over log 5. But if you notice in your calculator ready form is 1 over log 5. And so why is that? Well, we have to understand that. Well, what is log 10? Well, log 10 is really log 10 base 10, base 10, 10. And if I was to evaluate this, I know that x equals 1 because 10 to the x equals 10. There's a little invisible one up there, so whoops, you can't see that. There you go. There's a little invisible one up there, so x equals 1, right? So log 10 is actually the number 1. Either one of these I would accept, but I do want you to understand that log 10 is equal to the number 1, okay? So if you put that in, either one of these is acceptable, and then when I go through and I put this in my calculator, I can put this in my calculator as 1 divided by log 5, and I get 1.43067. So I get t equals 1.43068, right? And to 3 significant digits, it's 3 significant digits, so t is equal to 1.43. And that's how we turn these into equations that we can actually solve. How do we check those? Well, we could go back and we could check these by putting the t into the equation. So in my calculator, I can write 5 to the 1.43, but because we're not going to get exactly 10, but we should get something close to 10, right? The reason why we're not going to get exactly 10 is because we didn't use the exact number for t. If I go back and use even more of those digits, I should get something even closer to 10. So 5 to the 1.43068 should get me something even closer to 10, and look, it is. But it's going to be a little bit higher than 10 because I rounded the 6, 7, 8 into 6, 8. Okay? So that's what we did in class today. We could bring that to all of these other equations that would look a little bit more complicated. Okay, so what does this mean? This is 3.5 to the 2t equals 60. Okay, so this is a little bit more complicated, but again, we just rewrite it. Log 3.5 to the 2t equals log 60. And then I rewrite this as 2t log 3.5 equals log 60. And in order to solve for t, I'm first going to divide by log 3.5. So I get 2t equals log 60 over log 3.5. And in order to get this correct, I'm going to divide everything through by 2. So t is going to equal log, can you all see it? No, there it is. Log 60 over log 3.5, and then divided by 2. Okay? So that's what we have to do in order to get that answer. Once we do that, we do it. We do log 60 divided by log 3.5 equals this number. I divide that by 2, and I get to 3 significant digits, 1.63. That would be my t. Okay? Now again, how can we check this? I'm going to check this really accurately. That means I'm going to use this number in my checking. So I do 3.5 to the 2 times, oops, let's clear that out. 3.5 to the 2 times, oh, I can't use it because I did the answer. I'm going to try that again. Excuse me for that. Let's do that again. Log 60 divided by log 3.5 equals divided by 2. So now I have my answer. Okay, so now I'm going to go back to the original. 3.5 to the 2 times answer equals. There's the 60. So that means I know that this is right. So that's the way I can check this in my calculator if I did it right. Okay, so how does this, like, what's the issue with this, and how does this work with everyday math in the real world? Well, today we learned about something called compound interest. And it's very important to understand that compound interest has a very specific formula. And you'll see that the formula can only be solved using algorithms. Okay, so what does it mean to have compound interest? Well, it means that what if you decided you had $1,000 and you wanted to invest that $1,000? There's all kinds of ways you can invest this money, but if we were to look at what kind of ways does a bank or does some kind of money market account or things, what percentages, what rates will it give us in order to make this money grow? Okay? And something that we call compound interest means if I have something compounded, this money is making money every single day. So what does that mean? That means even if I make 3 cents on this each day, then my compounding interest means that I'm going to make money off of my interest, which means it's going to be an exponential equation. It's going to be something that happens bigger than if it was just a linear equation. So it's important to understand first we have to have this formula. This formula is A equals P times 1 plus R over N. Now here's where the exponent comes in, to the NT power. So this is where we're going to start using our logarithms. Now A is the total amount. P is something we call our principal, which is where we start. That means, so $1,000 would be my principal. R, of course, is the rate that we're getting it in. N is the number of times per year. Number of times per year that the money is being compounded. And I'm going to explain that in a second. But I still have to give you T. T is the time in years. Okay? So sometimes, if my money is not going to be making a lot of money, my number of times per year could be compounded yearly. So when my money is compounded yearly, n equals 1, because every single year the money is going to earn interest. But where you're really going to find it is something called compounded quarterly. And compounded quarterly means we're going to have 4 times a year that they're going to compound this interest. If you can get compounded monthly, then n is going to be 12, compounded monthly. And then clearly, if you can get it compounded daily, which doesn't happen, but we'll just pretend it does, 365 would be your n. So the question we did in class using this information is, what if you were able to invest your money, your $1,000, at 12% compounded quarterly? How long would it take you to triple your money or to make $3,000? How long? So that means we must not know our t, because we're looking for how long it's going to take. So let's do that. If I want to know how long it's going to take for me to earn $3,000 from my 1,000 principal, my A is going to be 3,000. My P is going to be 1,000. My R is going to be 12%, and we have to remember that we write 12% as a decimal, 0.12 or 12 100ths. Compounded quarterly means my N is 4. And again, my N is 4, and I don't know my T. So now I have all of this stuff. All I need to know is my T. And if you can understand, that's where we're going to use logarithms. But before we use logarithms, we're going to simplify this equation. The first way we can simplify this equation is by using our calculator and adding 1. Well, let's add this. 0.12 divided by 4 equals 300ths. So add 1 to that. I get 1.03. So that's going to be my new number inside my parentheses. And I still keep it to the 4t. And now I can simplify this even more by dividing everything through by 1,000. If I divide everything through by 1,000, I get 3 equals 1.03 to the 4t. Now this is where logarithms come in. This is exactly like the questions that we just did. Okay? We just rewrite this as logarithms. Log 3 equals log 1.03 to the 4t. We use our rules of logarithms to rewrite this as 4t log 1.03 equals log 3. Divide this all out by log 1.03. And then I have some work here that I have to do in my calculator. So my final answer here is going to be 4t equals log 3 over log 1.03. So I'm going to do this math in my calculator. Log 3 divided by log 1.03 equals this number. Now this is what this number is. In order to solve for t, I have to divide that by 4. So I divide this by 4, and I get 9.2917. So t equals 9.292, let's call it. And this is 0.3, right? So it's about 9 years and 3/12 of a month, right? I mean, 3/10 of a third of a year is about 4 months. So in order for you to triple your money, with 12%, you have to invest your money for 9 years and 4 months. And that's how this works. So I'm going to ask you to do some questions in the textbook regarding this. This is not a formula I'm going to ask you to memorize. You can always go back to your notes and look at what this all means.